Hey everyone, Chang here and welcome to my channel. Now, in a previous video, I talked about this large overarching picture of algebra, the whole study of algebra and how it can be broken down into different smaller chunks. One of the chunks I want to focus on today is the number groups. Now, my goal with this video, the previous video, and several others afterwards is to show you guys that every time you guys are introduced to some new topic, subject, equation, whatsoever, it's always going to be related to these chunks, which ties into this overarching study of algebra, right? They're usually not disjointed in any way. They might be presented in a way that seems like it has nothing related to each other, but if you guys can bring it back into one of these sections, then you'll see how they can work with each other. And guess what? The tools in that section, even though it might seem like it doesn't belong, can still be used if it makes basically sense, right? So I want to talk about this really quickly. Now, before anything, just a quick reminder, if you haven't watched that video, I'm going to put the link in the description down below so you guys can see it. But in the study of algebra, you have what we call axioms, right? Those are the undisputable rules. We're just agreed upon, because if we don't, well, we don't really have a study, right? Those are just agreed upon rules. And of course, there's different variations of what they consider is or is not an axiom. But the main result is that we have, of course, your additive inverse, additive identity, all that lovely stuff. But we also have the associative property, the commutative property, and the distributive property, right? These three are extremely important because guess what? Before algebra, of course, we were studying pre-algebra, arithmetic, so on and so forth. These work with the order of the numbers, and that's where stuff like order of operations come in, just so that there's no miscommunication. Okay, you have your orders of numbers, right? Because I mean, all math, we're basically studying numbers, and yes, there's an argument that we're using letters, variables, right? But of course, those are representation of numbers that we either don't know yet or generalized statement that usually involves working with numbers. So here's our orders. This allows us to order things around, whether that makes sense or doesn't make sense, right? If it's associative, if it's commutative, and then distributive property allows you to relate basically addition and multiplication together. So we have our way of ordering numbers. Then we have this other one, which is one that we're the most familiar with: adding, subtracting, multiplying, and dividing. Now this is a set of tools. This is what we call operations, right? But mainly you can just think of it as tools. What we can do with those numbers, right? We can either add them, subtract them, multiply, and divide them. Then, of course, you have your special cases, which I'm going to go into more details in just a little bit, your exponents, your logarithm, all that stuff. But basically, these are our four basic tools. Now, the other set of tools that's not really emphasized a lot, that we use almost all the time, is our comparison tools. The comparison tool is fairly simple. You have your equal, right? If two basically statements or two expressions, right? When we do numbers and we put tools with it, we call that an expression. We compare the expression. We have your equal, you of course have your non-equal, you have your greater than, you have your less than, your greater than or equal, less than or equal, and of course your roughly or an estimate kind of sign. So that's another set of tools. This is our comparison tools. Cool. Okay, so there it is. Working with numbers, we have our orders, then we have our tools, right? We're either operating on them or we're just comparing them to each other, right? It's something as simple as, is 5 equal or not equal to 3? And then you can say yes, no, whatsoever. Okay, now, this is where the nitty-gritty comes in, right? And there's a reason why in every algebra class, this takes up a good chunk of it. This is probably like, I want to say 3 or 4 chapters in almost every textbooks, right? Because this is very important. This builds up so that once you get comfortable with all the different tools, all the different things you can do with it, that when they throw variables at you, theoretically, it's not supposed to be confusing. Well, theory doesn't work all the time. So there it is. All right, so we have our tools, and now we use our numbers. So we have our number groups. We have our natural numbers, which is our counting numbers as well, right? We have our integers. We have our rational numbers. Then, of course, with the irrational and everything, we have our real number. And then, of course, now here's the thing. You also have your complex numbers, but I want to say this is sort of separate. Most of the time, this is never really introduced in the beginning, or at least very briefly just touched upon. You only see this more in probably Algebra 2 trigonometry when you start actually using and working with complex number, that this actually even shows up. So in a standard study of algebra, it's probably something along the lines of these guys. And then you have your special cases group, right? You have your even numbers, you have your odd numbers, you have your prime numbers, you have your composite numbers, and then of course there's a lot of different ways to break it down. You have your non-positive, you have your non-negative, and it depends on the author and what they want to break it down further. But basically these are the primary groups that you're working with. Okay, so you have your primary groups, and that's where you start seeing that all it is just a combination of these guys with these tools, right? If you're solving problems, basically simplifying, for example, simplifying, all you are really doing is comparing two expressions and realizing that they are the same thing. A classic example is like, for example, 2/4 is equal to 1/2, right? Even though numbers itself is different, the ratio and the proportion, if you compare them, right, they are equal. And hence, so you can, use cross multiplication, or you can just add them, subtract them, multiply, and divide them, and then you can change one expression to another expression. That whole thing is all simplifying and solving problems, right? So you have your simplifying and solving basic equations. Then you have your ratio and proportion that I just started talking about, right? Just comparing different fractions and all that stuff. So ratio and proportions. Now, what is ratio and proportion? And fractions? Well, fraction is nothing more than this guy right here. This is where fraction comes in, right? Your rational numbers have two representation. So let's just write this right here. So this one is, I'm just breaking down and pointing out, I guess you could say, common subtopics that you would see. And just to show you that this is just basically this guy interacting with this guy. Special cases of them is, in this case, the example that I want to talk about, like rational numbers. You have your fractions, and then you have your decimal as two different representation, right? And from fractions, of course, now you have this whole idea of simplifying, comparing, right? Ratio and proportion, which also give you that tool that seems disjointed, right? But cross multiplication. So now it's starting to get not as organized, right? You have your simplification, cross multiplication, and of course, working with fraction, you have your adding, subtracting, multiplying, dividing, and that's why you have the idea of common denominators if you're adding and subtracting, or you have your reciprocal, right? If you're dividing and multiplying. So common denominator, and you have your reciprocal, my spelling is probably not that great, reciprocal, and so on and so forth, okay? So what else do you have? Well, you have other things, right? What about exponents, logarithms? That's usually introduced in this category as well, because guess what? Exponent is special cases of multiplication. So of course you have your exponents. And then from exponent, you spawn two different possible smaller cases, right? You have the one with what happens if the exponent itself is not a whole number. So that's why you have stuff like square root, which is probably the most common one. And then other textbook might emphasize other ones like cube root, so on and so forth. But basically, that's what happens when you have exponents that are not whole numbers. Then, of course, with exponents, you have your inverse, because even though I didn't write it here, right? Inverse is a pretty big focus in terms of just axioms in general, or being able to just do the reverse of what a normal function or normal operation would do, right? So, of course, the inverse of exponent is your logarithms. Okay, so there it is. So this chunk right here takes a good chunk of the textbook, and most of them, hopefully you guys can see, are basically interactions of these guys and the tools right here, right? All these special cases that I'm just haphazardly thrown out there, hopefully you guys can see, is just that kind of relation. That's all it is. All right, so there it is. I'm cutting the video a little short because I don't want it to be that I'm just rambling way too much, and especially I don't want it to be such a long video where I go over every single section. So I'm gonna release it in like chunks. So this first video, I'm focusing on just the section 1, number groups, and we have our tools, basically our operation tools, our comparison tools, and then by intermingling and mixing these different tools with the number groups, right, we have all of these guys. And this is not a comprehensive list in any way. Like, for example, in fractions, I could go even further and say, we talk about, mixed fraction, you have your improper fraction, you have your standard fraction, and on and on and on and on. But the idea is that if you can relate them, understand that no matter how specific it is, right? No matter how disjointed it seems, like cross multiplication is just a simple tool. No, it's actually to work with ratio and proportion. What is ratio proportion? Well, that's working with fractions and decimals, and then that's just basically these tools comparing to each other and working with number groups, so on and so forth. I'm rambling again. Anyways, hopefully this at least ties it and make it a little more relatable, right? A little more so that you guys can understand how they are tied together, how they relate together. They're not disjointed in any way. So the first section, number one, number groups. And after you go through this, probably like a few weeks, maybe a month or so on, and once you get comfortable, that's when they throw in variables. And that's, of course, going to be our next section. And I'm going to go into details of the whole variable and how those are tied together and how, well, guess what? All the different special formulas, common equations, and so on and so forth relating to variables are tied together as well. So thank you for watching this video. If I haven't made you like super confused already, please like, comment, and subscribe. I will see you in the next video.